Welcome to the Causal Inference Seminar. Today we have Judith Lok from Boston University speak about causal organic indirect and direct effects closer to Barron and Kenny with a product method for binary mediators. In Q&A, we have two of her collaborators, Ariel and Ronald. She will also stop from time to time to take questions from the audience. After the talk, we will have a discussion by Kosuke from Harvard. After that, if we have more time, we will take some more questions. Questions during the talk will be handled by Guillaume, so I'm switching over to him now.
Hey everyone, so thanks Dominic. As usual, questions will be handled through the Q&A. So we have Ariel and Ronald who will do most of the answering on the Q&A. We will select a few questions to ask Judith during the talk. So please don't hesitate to ask questions. If your question is selected, I will ask you to raise your hand and unmute you. So that's as usual. All right, so Judith, you may start whenever you're ready.
Can everybody see my screen?
Yes, looks great.
So I will be talking about causal, organic, indirect, and direct effects, and I will focus on a method that makes these more resemble the original definition of indirect and direct effects by Baron and Kenny. I will also present a product method for binary mediators, and I will illustrate how these results can be used to estimate indirect effects of treatments, HIV curative treatments, with the effect of that treatment on the mediator combined with outcome data under no treatment. So no outcome data with treatment, but only outcome data under no treatment. This is joint work with Ron Bosch from the Center for Biostatistics in AIDS Research of Harvard University, and it is sponsored by the NSF and the NIH. And I would particularly like to thank also the organizers of the seminar for inviting me to present this work, and especially Michael, Dominique, Guillaume, and Guido for giving me the opportunity to present my work. Yeah. Indirect and direct effects decompose the effect of a treatment A on an outcome Y into the part that is mediated through a covariate M, that is typically called the indirect effect, and the part that is not mediated through that covariate M, and that is usually called the direct effect. For example, A could be a blood pressure lowering medication. The outcome Y could be heart attacks, yes or no in this case. And the mediation question in this case would be how much of the effect of the blood pressure lowering medication on heart attacks is mediated by the effect of that medication on blood pressure, and how much, if any, is going through other pathways. Another example, there are several potential preclinical HIV curative treatments A, and they typically target the HIV reservoir, let's tentatively call it M, and that may prolong the time to viral rebound after ART-interruption, and that is why. That's the outcome of interest, because in the end, the goal of these HIV curative treatments is to prolong the time to viral rebound after ART interruption. The mediation question in this case is, what is the effect of an HIV curative treatment A on viral rebound Y that is mediated through the effect that A has on the HIV reservoir M? The seminal article on mediation analysis that was written by Baron and Kenny and published in 1986 has over 94,000 citations in Google Scholar, and many of these are from the last 10 years. Mediation analysis is very important in the health sciences, and especially in epidemiology and psychology. Therefore, knowing the type of assumptions under which these analyses are valid and causal is very important. Many of these analyses are interpreted causally. So causal inference is really the natural way to look at these types of analyses, even when we are talking about randomized data. I will start with setting a notation, and I will focus for now on randomized treatment A. This can be relaxed. We will call the pre-treatment common causes of the mediator M and the outcome Y, we will call them C, as is in line with most of the causal inference literature on mediation analysis. When we want to estimate the part of an effect of a treatment that is mediated through a covariate M, it turns out that in order to have a causal interpretation, we do need the common causes of the mediator M and the outcome Y, even in a clinical trial. And this is an observation that has been made already in the causal inference literature for quite a while when identifying natural, indirect, and direct effects. My approach is no different there. I also need the common causes of the mediator M and the outcome Y. We will for now assume that there are no post-treatment common causes of the mediator M and the outcome Y. This can be relaxed, but that is not the subject of this presentation. As usual in causal inference, a subscript 0 will indicate without treatment, and a subscript 1 will indicate that that measurement is made under treatment. The DAG that is summarizing the data in this case is a DAG with the treatment A, the mediator M, the outcome Y, and this path that I just had, the path from A through to M to Y, is typically called the indirect effect, the effect of A on the outcome Y that goes through the mediator M. It's possible that A also has an effect on the outcome Y through other pathways, and that is this arrow that is usually called the direct effect. The common causes of the mediator M and the outcome Y are also in this DAG. As you can see, there is no arrow from these common causes C into A, because for now we are assuming that treatment was randomized. Causal indirect and direct effects are often defined in terms of the following counterfactuals. The outcomes under treatment had the mediator been set to the mediator without treatment. So these are typically denoted by Y1, M0. So there's a subscript 1 here for saying that it is the outcome under treatment. And there is an M0 subscript here because the mediator in this case had been set to the mediator without treatment, and that is M0. So it's the outcome under treatment with the mediator set to its value without treatment. There has been some discussions about these counterfactual outcomes. The first issue with them is that under treatment, M0 is not observed. The mediator under no treatment is not observed under treatment. So even if we could set the mediator, how to set it to M0 under treatment is not always very clear. This is not my main issue with these counterfactual outcomes. The second one has been bothering me a bit more. It is how to set the mediator is usually left unanswered, and that makes sure that sometimes these outcomes are undefined in practical situations. Cole and Frangakis in 2009 provided an illustrative example. There are many competing ways to assign, hypothetically, a body mass index of 25 kilograms per square meter to an individual. Each of them may have a different causal effect on the outcome. The way out that people use is sometimes to say it's the closest possible world to this one, where the mediator was set to its value without treatment and the patient was still treated. But what is this closest possible world to this one is not always very clear. In some situations it is clear. For example, Pearl in his 2001 approach has had a mediator that was aspirin use, a medication. In that case, setting the dose of aspirin use to a certain number may be feasible. In many applications, however, the mediator is also a covariate. And if the mediator is a covariate or blood value or patient characteristics, it's not always clear to set the it's not always clear how mediators can be set, and therefore it's not always clear how these counterfactual outcomes could be defined. That being said, if the mediator can be set to its value without treatment, there is a very elegant way to define indirect and direct effects. Those are called the natural indirect effects and the natural direct effects. The natural indirect effects, let's look at this difference. It's the difference between two counterfactual outcomes, and typically we look at the average natural indirect effect. We have here the outcome under treatment with a mediator at M1, because that's what happens under treatment. And here we have the outcome under treatment with a mediator set to its value without treatment. So both is under treatment. Here the mediator is set to its value without treatment, and here the mediator naturally comes at M1. So this is M1 versus M0. It's the effect that is mediated through M. It's the natural indirect effect. Then we also have the natural direct effect. In this case here, the mediator is set to M0. The mediator here naturally is M0. So in both cases, the mediator here is equal to M0. So this is not the mediated part. And that is called the direct effect. 1 versus treatment equal to 0. And these natural indirect and direct effects have been studied extensively in the causal inference literature. There is also an identification result for natural indirect and direct effects. I think that was presented in Pro 2001. And that mediation formula is very elegant. What you see here, we have what we are identifying. So for natural indirect and direct effect, we have to have the expectation of Y1 and the expectation of Y0. But in a randomized trial, that's easy. So the other ingredient in the natural direct and indirect effect is the expectation of this term here, and this term here. For that, there is the mediation formula, and we need the expectation of the outcome under treatment with the mediator set to its value without treatment. So what you see here is that first the common causes come about due to according to their population distribution. Then the mediator comes about, and let's look here. The mediator has to come about according to its distribution under A is equal to 0. And there it does. Given C, it has the distribution that comes under A is equal to 0. And then we look at the outcome. We need the expected outcome, but we need it under treatment. But with this particular mediator, so that's the mediator that comes from here, from this particular distribution. And we get the expectation of Y given that mediator, still given C, under A is equal to 1. When I first saw this result, I was very happy. I thought this was very elegant. And then later I learned that there were actually quite strong assumptions under which this mediation formula has been proven. And then I set about to try to find easier assumptions under which I could still get this appealing result. And today I will walk you through that journey. This mediation formula, under certain conditions, strong parametric assumptions, linear models, and no exposure mediator interaction, the mediation formula leads to estimators that are the same as those presented in the original work on mediation analysis from 1986. The causal literature thus adds a causal interpretation to those estimators. The causal literature also stresses the importance of including common causes C of the mediator M and the outcome Y, even in randomized settings. It also extends mediation analysis to different outcome types than the continuous outcomes that the original research was about. So there is a lot of good work already done on causal mediation analysis. There is one setback. Most causal methods need many counterfactual outcomes. They don't only need this outcome with treatment with the mediator set to its value without treatment. Most methods also need all the outcomes under treatment with the mediator set to any value of the mediator. And these outcomes are not always conceivable. There is an approach by Vanessa Dideles and co-authors that avoid these counterfactual outcomes, but they still need these counterfactual outcomes, the YANs. I present here an alternative intervention-based approach. There is a paper published in 2016 that this work is that I'm presenting today. There's also new work that I am presenting also today that has been posted on arXiv. I posted the last version yesterday, so that is the most recent version that is there. This intervention-based approach avoids cross-worlds quantities. It has simple assumptions. It has product methods, and it's especially useful in identifying indirect effects of treatments to select promising treatments for further investigation in randomized clinical trials. And I will present an example of that in HIV cure research. So an intervention-based approach obviously needs interventions. So what types of interventions? In this talk, will be an intervention on the mediator that does not affect pre-treatment common causes C of the mediator M and the outcome Y. Then we will talk about outcomes under treatment combined with this intervention I, and that will be I is equal to 1, and outcomes under treatment A combined with the intervention I. These are the mediator and outcome under treatment A and under intervention I on the mediator. An organic intervention is a specific type of such an intervention, and it satisfies two conditions. An intervention I is an organic intervention relative to A is equal to 0 and the common cause is C if, given C, the mediator distribution without treatment but combined with the intervention on the mediator makes the distribution of the mediator resemble the distribution of the mediator under treatment. The second condition, also given the common causes, if we condition on the mediator being equal to little m, whether that mediator came about without the intervention on the mediator or with the intervention on the mediator, doesn't have an effect on the distribution of the resulting outcome. This wiggly sign here indicates having the same conditional distribution. I is an organic intervention relative to A is equal to 1 and C if these two things hold but with a role of 0 and 1 reversed. So let's look at these conditions a little bit more. So the first condition says that given C, the I is equal to 1 changes the distribution of the mediator so that it resembles the distribution of the mediator under treatment. The second condition, one could say that I is equal to 1 has no direct effect on the outcome. We condition on C if the mediator is equal to M, whether that mediator came about without the intervention or with the intervention on the left, doesn't affect the distribution of the resulting outcome. This condition can also be relaxed by looking at conditional expectation of this one and this one given the conditioning event being equal. In order to have an intervention on the mediator that satisfies this second condition, one needs all pre-treatment common causes C of the mediator and the outcome. Without C, if we take this condition on C out of the conditioning event, when we condition on this mediator or this mediator conveys different information on C because the distribution of M0 and the distribution of M1 given C are different. So if we condition on this mediator versus this mediator, we convey different information on C. And C is also a cause of the outcome, so that would also affect the distribution of these two quantities. I will get back to this common causes of the mediator and the outcome later. So an example of an organic intervention. A is equal to 1 could be a blood pressure lowering medicine, M could be blood pressure, and Y the occurrence of a heart attack. The mediation question, does A is equal to 1 have a direct effect on heart attacks? For example, A is equal to 1 could lower the blood pressure by 10 without changing the shape of the blood pressure distribution. I could be then an intervention in the untreated that also decreases the blood pressure distribution by 10 without changing the shape of the blood pressure distribution. So we made sure that this I, this intervention of the mediator, makes the distribution of the mediator combined with the intervention resemble that of M1. For example, I could be a salt reduction in a dosage depending on C, perhaps a dosage with some specific distribution given C. The effect of salt on heart attacks is believed to be through its effect on blood pressure. So you could hope that if blood pressure has a certain value without the salt reduction versus it has a certain value with the salt intervention, salt reduction, then given the other patient characteristics, the people with the blood pressure equal to M without the salt reduction and the people who have the blood pressure equal to M with the salt reduction have the same distribution of their heart attack variable for this intervention I. So what does the salt reduction do? It keeps the effect mediated by the effect of A on blood pressure M. So this stays the same. The effect that the salt also decreases the blood pressure by 10. And it doesn't have the direct effect that A is equal to 1 might have or might not have, that we are going to investigate. And this makes gets us to the organic indirect effect of a treatment A relative to A is equal to 0 and C, and the organic direct effect of a treatment A relative to A is equal to 0 and C. So here what we have is by I is equal to 1 is still the outcome under treatment A and under intervention I on the mediator. The indirect effect, here the mediator is equal to M0 because these people are not treated. These people have the intervention I is equal to 1, they're also not treated, but their distribution of the mediator is the distribution of M1 due to the intervention I. So here the distribution of the mediator is M1, and here the distribution of the mediator is M0. So this could be thought of as a mediated effect. It's both under treatment equal to 1, mediator M1 here, and M0 here. Then we have the organic direct effect of treatment A relative to A is equal to 0 and C, also based on I. And here we have the no treatment, and the mediator distribution is M1. And here the mediator distribution is also M1, but these people are treated. So treated versus untreated, M1 versus distribution of M1, we could think of this as an organic direct effect. We can also define organic indirect and direct effects relative to A is equal to 1, and that is in fact the version that I presented in 2016, and that's defined similarly, but with the role of A is equal to 0 and A is equal to 1 reversed. Whether an intervention is organic can and should be discussed with subject matter experts. I have shown that organic indirect and direct effects in fact generalize natural indirect and direct effects in many occasions, provided that the intervention that sets the mediator to M0, recall that natural indirect effects are defined with outcomes under treatment with the mediator set to its value without treatment. So if we think of this setting the mediator to its value without treatment as an intervention, we can say that we are looking at outcomes under treatment with the mediator set to its value without treatment. Under that intervention, the mediator has the value without treatment. If this intervention exists, the usual crossroads assumption implies that the intervention I that sets the mediator to M0, so this particular intervention, is in fact an organic intervention. So the organic indirect and direct effects generalize natural indirect and direct effects. In order to get an identification result, I need a consistency assumption, and that's the usual consistency assumption that if we have a person treated, we've observed their treated mediator and outcome, and if patient is untreated, we observe their untreated mediator and outcome. And that's about it. We don't need many other assumptions. I here have a mediation formula for randomized data for organic, indirect, and direct effects. The assumptions is that treatment is randomized. We have this consistency assumption that I just showed you, and the definition of organic interventions. Then for an intervention I that is organic relative to A is equal to 1 and C, we find that the expected value of the outcome under treatment combined with an organic intervention follows the mediation formula, the beautiful mediation formula that came from the causal inference literature. So first the common causes come about, then the mediator comes about according to its distribution under no treatment. That is what I is equal to 1 was doing. And then the outcome, expected outcome, comes under A is equal to 1. And that is because it's a treated outcome. One thing to notice is that this turns out not to depend on which choice of organic intervention I was chosen. So that means that whatever organic intervention I is chosen, the indirect effect doesn't depend on I. It may still depend on C, and I will come back to that. This mediation formula is the same mediation formula as previously found for the natural indirect effects studied by previous authors. And also the idea to include the common causes comes from the causal inference literature. This work really works on the works of giants. The resulting expression is in terms of observable quantities only. All 3 ingredients can be estimated using standard methods. My contribution is that the definition and therefore the interpretation of indirect and direct effects and the conditions under which estimators for these effects are valid can in fact be considerably relaxed. And let me see whether now I will be interrupted to give a question and answer.
Just a quick clarification, Judith. When you're talking about organic intervention for practitioners, do you actually look for such interventions and see if there is any intervention that might reasonably be considered organic, and this way strengthen the interpretation of these approaches? And what happens if you can't imagine such an intervention actually taking place? Do you actually revert back to the kind of like natural direct and indirect effects interpretation?
So yes, no, and yes.
Okay.
So yes, I usually try to think of organic intervention. I usually try. It is not necessary. What you get is the effect of an organic intervention, would there be one. Do I go back to natural indirect effects? Me personally, no, because if we can imagine setting the mediator, and we believe that there is some unique way in which the mediator can be set, then under the usual condition, setting the mediator to its value without treatment is an organic intervention. So this is a generalization. I don't need to go back because I'm generalizing. Yeah. Makes
sense. Got it. I think there are no other questions at the moment.
Then I will continue.
Yep.
Okay. So this intervention-based approach answers questions about the effect of interventions and what one might expect from interventions that satisfy certain conditions. Now I am going to do something that is in the 2020 paper more than in the 2016 paper. Combining organic interventions on the mediator with treatment follows analogies with mainstream natural indirect effects, because natural indirect effects are typically defined in terms of the outcome with under treatment, with the mediator set to its value without treatment. So we combine setting the mediator without treatment, with A is equal to 1. In that situations, as is well known, the product method from Baron and Kenny works only in linear models when there is no treatment-mediator interaction in the outcome model. However, one can also combine organic interventions on the mediator with no treatment, so with A is equal to 0. And this in fact is similar to the pure indirect effect, that was presented first by Robbins and Greenland in 1992, and that also is covered in detail by Nguyen in collaboration with Elizabeth Stewart in their work in 2020. If we combine organic intervention on the mediator with no treatment, the product method works in linear models regardless of whether there is treatment-mediator interaction in the outcome model. And this is what the term closer to Bardon and Kenny refers to in my title. Combining organic interventions with no treatment also has an interpretation advantage, especially in an interpretation advantage in the indirect effects. Because the interpretation of the indirect effect, when we combine interventions with no treatment, the organic indirect effect is the effect of a treatment that affects the mediator the way A is equal to 1 does, but that has no direct effect. Because after affecting the mediator M, Y follows its course as though there was no intervention I or treatment A. I also proved the mediation formula for organic indirect and direct effects relative to A is equal to 0, and the proof is no different from that for A is equal to 0, A is equal to 1. Again, the common causes come about first. In this case, the mediator distribution is as under treatment, so we found the mediator distribution under treatment, and then the outcome under no treatment, but with this mediator value, so we get the expected outcome under no treatment. And again, it does not depend on the choice of organic intervention I. And I promised that I would get back to its conditioning on C. So let's go look how that works. If C has all pre-treatment common causes of the mediator M and the outcome Y under treatment A, the organic indirect and direct effects relative to A are unique. Which set of all pre-treatment common causes C is chosen does not affect the organic, indirect, and direct effects. And this is a result that I proved in 2016. Therefore, we can define, and I was suggested to do this by one of the referees, when C includes all common causes of the mediator M and the outcome YA, we call the organic, indirect, and direct effects based on I relative to A and C the organic, indirect, and direct effects relative to A. So now the dependence of C has disappeared as long as C has all common causes of the mediator M and the outcome YA. And one can define this very similar to what Pearl has. X is not a common cause of the mediator M and the outcome YA given C if either given C, X doesn't predict M0 and M1, or given C and the mediator under treatment A, it doesn't predict the outcome. In graphical language, X is a common cause of the mediator this should be M. X is a common cause of mediator M and outcome YA. If in a deck that has C, X, M, and YA, there is an error from X to M, and there is a direct error from X to YA. And this definition is in line with, for example, what Pearl has in his book on causal inference. I promised you a product method for binary outcomes. For binary mediators, not binary outcomes, for binary mediators. For binary mediators, under the conditions for the mediation formula, the organic indirect effect relative to A is equal to 0 equals what is here. So let's forget for a moment about conditioning on C. When the distribution of C, when we condition on C, it is the effect that A is equal to 1 versus A is equal to 0 has on the mediator, conditional on C. So the effect of A is equal to 1 versus A is equal to 0 on the mediator, times the effect that a change from M is equal to 0 to M is equal to 1 has on the expected outcome given under treatment A is equal to 0. So it's the effect of treatment on the mediator times the effect that the mediator change has on the expected outcome under A is equal to 0. And this is averaged over the distribution of the C. If we look at a conditional mediated effect, so a conditional indirect effect, as Tyler Vanderweel has in his book on mediation analysis, it's a true product because we just condition on C. If there are no common causes of the mediator and the outcome, it's also a true product. Otherwise, it's an average over these products. And then we could estimate it by, for example, doing the empirical distribution over the C's that have been observed in our sample. If A increases the probability of M is equal to 1, the organic indirect effect relative to A is equal to 0 is the increased probability that we have M is equal to 1 times the effect that changing from M is equal to 0 to M is equal to 1 has on the outcome. And that's averaged over C. One thing that you see in this mediation formula, if we have this organic indirect effect, we see that we have the probability of M is equal to 1, both under A is equal to 0 and under A is equal to 1. But we have this difference between expected outcomes only under A is equal to 0. And when we look back at the mediation formula, we also see that for this expected outcome, we only need the expected outcome under A is equal to 0. When we look at the indirect effect relative to A is equal to 0, we subtract the expected outcome under no treatment. Also for that, we only need outcome data under no treatment. And that's an important observation, because that means that the organic indirect effect relative to A is equal to 0, this quantity here, can be estimated with the distribution of the mediator under treatment, that is under A is equal to 1, and under no treatment, A is equal to 0. But we need the expectation of the outcome Y, given the mediator M and pretreatment covariate C, only under no treatment, under A is equal to 0. And that has important advantages in the preclinical stage for the selection of new treatments with promising indirect effects for clinical trials. And I will illustrate that with an HIV cure example. Do we need questions again?
Yes, so we have a couple of questions, related both to the connections between your work and instrumental variables. One of the persons who asked the question doesn't have good audio, so I can't give them the mic. But the question was about the connections with instrumental variables, if any.
I don't know.
Okay. Okay. Yeah, that's good. Yeah, we can all think about that. Yeah, and the other questions are being taken care of.
If I would want to know about the connection, I would ask Eric Chedgan.
Okay.
Because he knows a lot about mediation analysis and a lot about instrumental variables. I know some, I can teach it, but I am not an expert on instrumental variables.
Sounds good. Thank you very much.
Okay.
Oh, and sorry, you have about 10-ish minutes left.
Oh, that's great. I will do the shortcut as I promised.
Got it. Thanks.
Okay, so let me look. I will go to the deck. So I will not present the details of my HIV application, but I will present the main ideas. So this is the HIV cure setting that I have been studying. I have been studying the effect of curative treatments on the time to viral rebound. And especially, I have forgotten about this arrow here because I cannot estimate it. I have been trying to estimate the effect of curative treatments that are mediated through the viral reservoir on the time to viral rebound. So typically what the curative HIV treatments are trying to do is to delay the time to viral rebound. And the time to viral rebound is the time in which the virus, the HIV virus, is detectable again in the blood of HIV positive patients. In order to measure the time to viral rebound, treatment, or not treatment, but ART needs to be interrupted. Most HIV positive patients are on ART, and most of them are expecting to be on ART until science has found a cure. For some, that may mean for the rest of their lives. But the HIV cure is aiming to attack the viral reservoir, hopefully to completely eradicate the viral reservoir, or at least make sure that the reservoir is so small that the time to viral rebound is very, very long, maybe even until never observed because patients have died from other causes. So we have here a treatment, a curative treatment, HIV treatment. It's aimed at the viral reservoir to reduce the viral reservoir. But finally, the hope is that it will delay the time to viral rebound. This is our treatment. This is our mediator, viral reservoir, and this is the outcome, time to viral rebound. There are also common causes maybe of the viral reservoir and the time to viral rebound. In this case, we are looking at pre-ART viral load. That is a common cause. We don't have information on that, so we have we have some information, but not for all the patients. So instead, we have used a surrogate, that is the nadir CD4 count. That is a common cause. The interesting part about this HIV application is that in order to find the time to viral rebound, patients have to interrupt ART. And interrupting ART is dangerous because the virus comes back up, and that is known not to be good. So people have to be monitored really closely in order to do that safely. That obviously also comes at considerable cost because they have to be monitored very frequently. Also, it's kind of hard to find patients to do this because it's not in their best interest to do this. They are doing this to move science forward because typically the time to viral rebound these days is like 4 weeks, 8 weeks. That is already quite a big of a success of the curative treatments. And you take the ART for life. So having the viral rebound already in 4 or 8 weeks doesn't really benefit the patients that are participating in these trials. So it is important to try to use the existing data that we have to figure out which treatments are most promising in terms of their effect, and that then can be tried in clinical trials. What we have done is estimated the organic indirect effect relative to A is equal to 0 of a new curative HIV drug A. That is the effect of a new curative HIV drug without a direct effect. That shifts the distribution of the mediator M by 1 log 10 given C. By 1 log 10 because the reservoir measures are typically measured on a log 10 scale. So this is M1 that has a shift of the mediator distribution of 1 log 10 compared to the mediator distribution without treatment. So this is a 10-fold reduction of the HIV reservoir given C. This is a shift in the distribution of the mediator and not a shift of actual values. In terms of causal inference, we are not doing rank preservation. We can, however, estimate the distribution of M1 under this shift by subtracting 1 log 10 from the mediator M0 under no curative HIV drug. The data that we have is the ACTG data from Lee et al. From 2016. There are 124 HIV-infected patients without curative interventions, so A is equal to 0, with on-ART HIV reservoir measures M, and with ART interruptions and viral rebound measurements Y. So all the measurements that we have are under A is equal to 0. But because we need outcome data only under A is equal to 0, and we posit this model that we say, okay, we are looking at a curative HIV drug that hopefully reduces the viral reservoir tenfold, we can still estimate the indirect effect of this intervention on the viral rebound. And here are our results. We have 2 mediators, single copy assay HIV RNA and cell-associated HIV RNA. We have looked at viral suppression, yes or no, so a binary outcome at week 4 and at week 8 of ART-interruption. We have looked at several shifts of the mediator. Here we present 0.5 log10 on the shift, a 1 log10 shift, so a 10-fold reduction of the mediator values. And here, because these mediators also have an assay limit, we looked at what if all the mediator measures go below the assay limit. And we then found the indirect effects on a risk difference scale of treatments that result in such shifts of the mediator. And here are the indirect effects that we find for single copy assay. And here are the indirect effects that we find for cell-associated HIV RNA. The week 8 analysis is more interesting from an HIV point of view. And you see that here, it seems like a shift of the cell-associated HIV RNA results in bigger indirect effects than a shift in the single copy assay HIV RNA, which would suggest that this is a better target for treatment shifts than the single copy assay, although that may also be due to measurement error that is present in both these mediators. And I will get back to that later. Also, the one has a higher probability of already below the limit of detection than the other one. So that may also be a reason that these effects differ, I should say.
Judith, can you maybe wrap up in 2 minutes or so?
Yes, I can.
Great, thanks.
So, what did we obtain? The organic indirect effect relative to A is equal to 0 of a curative HIV drug that shifts the distribution of the viral reservoir by 1 log 10 given pre-treatment common causes C, estimated from existing ART interruption data under no curative intervention. A is equal to 0. That is the effect of a curative HIV drug that shifts the distribution of the viral reservoir by 1 log 10 given C, and that has no effect on viral rebound. Conclusions. Both for natural indirect and direct effects and for the randomized indirect and direct effects that Vanessa Didelix and co-workers have proposed, one needs to be able to set the mediator to any specific value. We call these YAMs. Organic indirect and indirect effects need to be able to affect the distribution of the mediator. Organic indirect and direct effects relative to A is equal to 1 generalize natural indirect and direct effects. To answer clinical questions, it is often useful to combine interventions on the mediator with no treatment rather than treatments. And this is analogous to pure indirect effects of Robbins and Greenland. They also have the total indirect effects that are more like the natural indirect effect. Organic indirect effects relative to A is equal to 0 can be estimated with information on the mediator distribution under treatment and no treatment, but you need outcome measurements only under no treatment. And that can be beneficial in the preclinical stage for selecting new treatments with promising indirect effects for clinical trials. It also brings causal mediation analysis closer to Baron and Kenny, and leads to a product method for binary mediators. Although there are also a product method that I can show you if you ask for the natural indirect effects. And here's some remarks on future and ongoing research. I would like to look at measurement error. We are also looking at what if the outcome logistic regression model also holds for mediators below the assay limits, and I'm working on that with Ari Chernovsky from Biostatistics at BU. And I'm looking at the inclusion of post-treatment common causes of the mediator and the outcome. And I'm interested also in working on other applications and figuring out which is the next one. Thank you all for listening. Thank you all. Thank you to my reviewers, the organizers of the seminar, the HIV-infected participants who gave the trials. I am really standing on the shoulders of giants, and I would like to thank everyone. Thank you.
Fantastic. Thanks for the great talk, Judith. We will now switch over to the discussion. So we will have Kosuke present some slides, and after that, Judith can respond. So I'm now switching to Kosuke. Yeah, you can start.
Okay, does this work?
Yes.
Okay, great. Thanks for having me to discuss this paper. So I'm gonna just go quickly. So I first wanted to sort of describe the contributions of the paper. So for me, it's sort of reinterpret the mediation formula that's been widely used in terms of this new causal quantities was introduced by Judith in her 2016 Statistics in Medicine article. It avoids cross-word counterfactuals that I think a lot of people criticized standard mediation analysis. And most, I think, importantly, this uses the idea of stochastic intervention on the mediator. So I think this connects to not just to the mediation analysis per se, but the much broader application of this type of method and quantities. She also shows that in linear models, these effects under the control condition equals the product method of Barron and Kenny, which is being used quite a bit in applied research. There's no assumption that is necessary about the interaction, and it's different from the organic indirect direct effects under the treatment condition. And then she presents the application to HIV treatments, which I don't have any expertise, so I'm not going to talk about this. Okay, so I always wanted to put this in the notation that I'm a little bit more used to. So this is the natural indirect effects, where you fix the treatment to A and then changes the mediator from the natural value under the control condition to the treatment condition. A natural direct effect is the opposite. You fix the mediator at the natural value under the treatment condition A and then changes the treatment from 0 to 1. So this is the standard sort of natural indirect direct effects. The problem is that we must infer cross-word counterfactuals. So fixing the treatment A while thinking about the value of the mediator that would be realized under different treatment conditions. So this is a counterfactual that's not observable once when the A and A prime is different, right? So it's not even potential outcome, it's like unobservable outcome. So even in the randomized control trials, we need the cross-word independence assumption. So conditioning on the treatment assignment, you have to assume independence between this potential outcome, which is under A prime, and the mediator value under the actual realized A. So that is a very strong assumption that's necessary. And most importantly, randomization of mediator doesn't really satisfy this. In addition, no post-treatment confounders allowed. So these are two limitations that I think is being criticized, used to criticize the standard mediation analysis. The organic indirect direct effects is a bit different. So I used a slightly different notation, but basically it averages over potential outcomes over the distribution of the mediator under the control condition. This is the original quantity that was presented in our 2016 paper, and direct effect is similar in that you basically averages over expected value of potential outcomes over the distribution of the mediator under the control condition. So now you can immediately see that this is identifiable if you can randomize the mediator. This is also identifiable once you randomize the treatment. So these two quantities are identifiable without any cross-word counterfactual assumption. Sometimes you might condition on the covariates, but the idea is the same. So that's basically the attractive property of this new quantity that Judith talked about. So to me, like you can contrast this with the natural effects counterpart. So the natural effect counterpart is this quantity that people are uncomfortable with. So under control condition, what is the value of the mediator? But you have to still fix the treatment to 1, right? So that's the incompatible sort of quantity. And you can write it this way, and immediately you realize that the cross-word independence implies these two things are independent, so they drop out. So that reduces basically the natural effects to the organic indirect effects. Basically, this part becomes equal to that part once you drop it. Okay. So in the paper, there's a statement about the relationship between these two effects, and then claim is that it organic, indirect, and direct effects, generalized, natural, indirect, and direct effects. But it seems to me that, so the questions I have is, natural effects become organic effects under cross-word independence assumption. So it almost as if organic effects are special cases of natural effects. More importantly, I wonder what it means to say, you know, the M1 under the intervention, the stochastic intervention, equal M0 exists. So to me, for natural effects, the intervention is about individual values, like you said, like setting individual values. Whereas for organic effects, it's about their distribution. So it was unclear to me like when they coincide, and it seems they only coincide in the limiting case where the mediator is basically a deterministic function of the treatment and perhaps covariate you're conditioning on. But that would lead to the violation of the positivity assumption. So I was curious like how those two relationships, two quantities seem to coincide. Okay, and just given the time, I'm gonna just quickly, so the new direct effect and indirect effect, as Judith talked about today, is basically a flip side. So setting the treatment to 0 instead of the to 1. And with this new definition, the product method works for linear models, regardless of whether the outcome model has treatment mediation interaction. This result seems consistent with the standard results for the natural effects. And the product method for the binary mediator is also, that formula is also applicable to the natural effects. And I guess that's not really surprising because once you assume cross-word independence assumption, they coincide. So the formula seems to, you know, the same formula seems to be applicable to the both type of effects. Okay, so just to wrap up, this new quantities that Judith introduced avoids cross-word counterfactuals, yet the same mediation formula and all results still apply. So it's nice sort of combination of avoiding the controversial assumption, but you can use the still same formula and methods. Different basic interpretation, but same methods. But appropriateness depends on obviously applications. And the future research, I just wanted to mention this connection to the stochastic intervention mediators, and you know things like two-stage randomization, interference, that also can be seen as a stochastic intervention. So I think there's a lot of connections to other types of analysis. It's potentially useful for high dimensional mediators. I think setting the particular values, if it's low dimension, it's easy to imagine, easy to do, but if it's high dimensional, the distributional intervention could be very, very useful. So that's the comments I have. Thank you.
Fantastic. Thanks, Kosuke. Judith, do you want to respond, perhaps?
Do that. Sure, I will do that. Thank you, Kosuke, for these remarks. This is very useful. I agree with most of what you said. In terms of our organic indirect effects, a special case of, let me see where I can find it. So are organic direct and indirect effects a special case of direct and indirect effect, natural ones? I think it's more really the other way around. The natural indirect and indirect effects only work if you can really think of setting the mediator. Where, for example, in HIV cure research, you would want to set the HIV reservoir to 0 if you could. And it's not possible. We cannot set it to any particular value, but there are interventions, or I would say treatments. There are treatments, potential cures that are not working that well at the moment yet, but that may lead to other better medications that affect the distribution of the mediator. And I think that is not exactly what natural indirect and direct effects are aiming at. So it's really looking at interventions that affect the distribution of the mediator. And I can follow up showing that. So what do I mean? You asked, what do I mean by the mediator under treatment with an intervention combines sets the mediator to M0. What do I mean by that? So this I can probably best say, like, if there is the closest possible world to this one and everybody agrees on that closest possible world, where the mediator is set to its value under no treatment while the people are treated. If we can think of such a situation that really they set the mediator to its value without treatment, then the usual identifiability for natural direct and indirect effects that I found in the literature is this one. I think you have this also on your discussion. Then if this identification assumption that is usually used for natural indirect and direct effects it holds, you can show along these lines that I won't go into, but you people who are interested can look at my slides. Then that implies that this setting the mediator to M0, that is an intervention on the mediator, is actually an organic intervention. So that is the first thing that I wanted to say. The next thing is that you asked about a product method. I think it's here. A product method for I don't see it. This is relative to A is equal to 0. I want the product method for binary mediators. Here. Product method for binary mediators approved for natural indirect effects. And that I have here. The result is that it is the effect that the A is equal to 1 versus A is equal to 0 has on the mediator. But we look at the expected difference between outcomes of changing from M is equal to 0 to M is equal to 1, but now under treatment. So the funny part here is that for here, we don't need outcome data under A is equal to 0 in order to estimate the mediated, the indirect effect through this mediator. And that in fact is the case for natural indirect effects, the way they're usually defined in general, that you don't need outcome data under treatment in order to estimate these natural indirect effects. And I agree with you completely that what is the most relevant quantity to look at really depends on the application. In my HIV cure application, I think it's really combining the intervention on the mediator with no treatment. But if, for example, the effect is if your intended effect is to figure out what if we could prevent certain side effects of a treatment, in that case, it's more relevant to look at combining interventions on the mediator with A is equal to 1. So I agree completely with you. That is also depending on the application of interest. For drug development, I think it is really valuable to have a combination of the mediator intervention with a setting of no treatment, especially because you can have outcome measurements only under treatment, under no treatment, and those may be available from placebo arms in previous trials or from the general population. And then people may often have a good idea ahead of time of how they at least hope that treatment will affect the mediator, because typically treatments will target a certain biomarker that you can then treat as a mediator, and then you can try to estimate the indirect effect using population data or previous clinical trial data from placebo arms to estimate this expectation of the outcome under no treatment and combine it with your effect on the mediator. That's all I wanted to say.
Fantastic, thanks. I think we're now running out of time, so I think we should quickly wrap up. First of all, thank you so much, Judith and Kosuke, for a great presentation and a very interesting discussion today. Next week we will have a joint presentation by three authors. We'll have Cynthia Rudin, Alexander Wolzowski, and Sudeepa Roy, who will talk about almost matching exactly. The discussant next week will be Guillaume. So you've heard a lot about him already during the seminar series. Finally, now you will see more of him here on screen. We're very much looking forward to next week. Thank you all for joining. I hope you all stay safe and have a good week. Thanks, and see you next time.